Thank you. Thank you for being with us for this last talk today. My name is Nawal, and I'm product manager, and I'm here with Marta, who is risk manager. And we are both working for Varian. Varian is a medical device manufacturer. And I guess like any other medical device manufacturer, when it comes to development, safety is always at the heart of the development. And our topic today is how we are building safe software for cancer patients with the ultimate goal to have zero harm in patient care. First, do no harm. This is a very important and old principle from Aristotle, and it's still actually taught today in healthcare schools to students. And basically what it says is like if you have a problem, so a healthcare problem, it is better to do nothing rather to do something that can cause more harm than good. This is also actually important for us as medical device manufacturer, because we need to make sure that our products are safe. We want them, of course, to be safe by design, that they cannot cause any harm. This is unfortunately not always possible. So we need to make them at least as safe as possible, and making sure that we are not affecting the benefit-risk ratio. Let's define what harm means. So harm is a damage or a physical injury to the health of a person. It can as well be actually damage to property or environment. In our case, we will really just focus on the person, on the people harm. And it can go from anything from discomfort, inconvenience, until the most extreme case where you have permanent total disability or even death. I think it's important to first understand the workflow, in which context we are working. So we will say some words about radiation therapy, which is our core business. Marta will share with you some of the reported cases of mistreatments. She will then give you an overview of how we are building safe software. And finally, I will present to you some of the innovations that are having an impact on the quality of products and on the patient safety. Okay, cancer patients, yeah. So that's something I think that touch or will touch directly or indirectly any of us. Luckily, there are quite some therapies and solutions today, treatments that are available. You have surgery, which is really the removal of the tumor, or you have chemotherapy, which is the treatment of the tumor with medication. And here in the center, we have radiation therapy, which is the use of high energy radiation coming from X-rays, for example, but can come from other sources. And this radiation actually is going to damage the DNA in a way that it will kill the cells. It damages luckily more the tumor cells than the healthy cells. And the goal then is really to kill the tumor or to at least shrink the tumor. At the same time, you need to make sure that you are not going to touch the healthy cells that are around, because they are also impacted by this radiation. So in Varian, our core business is really the radiation therapy. And I want you to have just a quick overview of the company. So it started back then at the end of the 40s with the Varian brothers in the Silicon Valley. And already in 1960, we had our first linear accelerator that was introduced. So the linear accelerator is basically the machine that is creating this high energy radiation, and that is going to treat the patient. And if we now leave the Silicon Valley and come back to Switzerland, to Baden, there was this division in ABB that was specialized in radiotherapy as well, and it was acquired by Varian, and today we are a research and development center of excellence in imaging, and we are around 400 employees, many engineers, software, hardware, system engineers, quality engineers, project and product managers. Our vision is a world without fear of cancer, and since 2021, we are combined with Siemens Healthineers with the goal of accelerating the fight against cancer. I want to show you actually how a radiation therapy treatment looks like. So once that cancer is diagnosed, then the doctors decide which therapy you will get. And if they decide that the patient will get radiation, then the patient is at some point invited to the radiation therapy department. The therapist is there to welcome the patient, place the patient in the... Oh, I have it point there. Place the patient on what we call the couch, so it's this table top. Remember, radiation is going to have an impact on the tumor cells, but as well on the healthy cells. So it's very important to make sure that you are going to treat only the tumor cells. And so the first phase of this treatment is going to be to acquire an image, a 3D image. Let me start the little video. So here you can see the machine, so the gantry going around the patient, the imagers coming out. A 3D image, so image is getting acquired, and 3D image is going to be reconstructed. And based on this treatment image, the couch, so the table where the patient is laying, is going to move to perfectly match what is planned to be delivered. Once that this is done, treatment can start. So here we represent in this kind of purple or red color the tumor. So the goal is really just to treat the tumor. And again, you will have the radiation that is going to be delivered to the patient. Okay. Before this treatment can start, there is a whole workflow before. I mean, we don't need to go into the details of the workflow. What I would like you to remember is that between the moment where there is a CT scan of the patient and the moment where the treatment starts, there are a lot of work happening in that department. It goes from prescription, from planning, which is kind of an optimization, a multidimensional optimization of where the treatment is going to happen, and some quality check. And this is done by different people at different time, and it's very time consuming. It can take, in average, they say, 1 to 2 weeks. So it's only after that the patient comes and the treatment can start. Treatment can be a couple of weeks. So it's every day from Monday to Friday. During 3 weeks, then the patient would come to get this treatment. So takeaway messages: complex treatment, many people involved, many steps, quite long. This means that it's also error-prone. And this is leading us to the next part with Marta about the reported cases of mistreatment in radiation therapy.
Thank you. Thanks. So, where do we find these cases? There are several public databases where we can find them. Here you have a couple of them. So this is SAFRAM, the Safety Reporting and Learning System for Radiotherapy from the International Atomic Energy Agency. And we also have MOD. This is a manufacturer and user facility device experience from the US Food and Drug Administration. So the cases we will see are coming from these two databases. First case. Imagine there are two patients in the waiting room. These two patients, they have a similar name. See here on the top, patient 1 and patient 2. They are around the same age, maybe a year difference, the same height and the same weight. And they're both planned for pelvic radiotherapy. So the radiation therapist just returning from vacation does not recognize the patient from the face, and moreover, does not recognize the images on the screen belonging to the patient. So what happened? Yes, the wrong patient was treated. And this can even happen with patients that don't have a similar name. Second case. Sorry. This is a bolus. This is an accessory. So this is made of equivalent to human tissue material, and it's normally used on top of the patient to bring the dose to the surface of the body. Sorry, put it back. So in this second case, the patient was on the couch, and one of the team members was speaking to other team members about other subjects, and signed off that the bolus was in place without verifying that actually the bolus was in place. So there's no barcode to scan, there's no reference ID, so you put it on top of the patient. So in this case, the patient was treated for some time without the bolus in place until they noticed this. Once they noticed, they stopped the treatment, they put the bolus in place, and they continued with the treatment. Third case. The patient was imaged, so this is the first step of the process that my colleague Naval explained before. And the team member that was signing the report signed that the tumor was on the right side when it was on the left side, so the wrong side of the body. And the whole treatment plan was based on this. As a result, the patient was treated for 2 days with this plan. Once they noticed this, they interrupted the treatment. They had to talk to the patient. They had to replan everything again based on the correct side of the body and treat again. So in terms of harm, imagine this causes treatment delay. This can cause also psychological harm to the patient. So don't have to forget different type of harm. Fourth and last case. Clinical patient database was accidentally deleted at a customer site by a service employee. Although this was immediately noticed and they tried to restore to a backup, they had a non-checkpointed backup. In this case, there was a software error where the checkpoints did not work. So during 3 weeks, the system was in an inconsistent state. And during 3 weeks, they had to manually record in terms of data and workflow progress what happened, the treatments. Another quote. To err is human. To cover up is unforgivable. To fail to learn is inexcusable. So as we've seen just before, these cases can and do happen, and we need to learn from them. We need to learn from potential mistakes. With this, we can improve our products and we can deliver safer products, which leads us to the next topic, building safe software. Medical device manufacturers are highly regulated by regulations and standards. We need to ensure that we deliver safe products to all those who are exposed to them. And how do we do that? Throughout the product life cycle. Sorry. We start with the concept. Is it a medical device? What are the resources needed? What's the regulatory strategy? What's the risk, the harm? From project start to project end, we have another phase. Design and development, ending up with the product ready for market. During this phase, we also have some other activities going on in parallel. These are related to risks. This is what we call the pre-market risk phase, pre-market risk activities. So during this phase, we have the first step, which is the analysis. What can go wrong? So the medical device manufacturer has to think of all the possible safety characteristics of the device. Once the analysis is done, we have to evaluate what can go wrong, what is the harm, what's the risk, what's the probability, what's the severity. And once the evaluation is done, we need to put some controls in place. So primarily, we should have software which is already safe by design. And when this is not possible, then we should put some controls in place. There are several standards and regulations to help us or to guide us on how to do this. And once the controls are in place, we need to evaluate again, not only the residual risk individually, but also the overall residual risk. Is it acceptable or not? And all of this is later on documented and signed. Once the product is released, until the end of life cycle, we also have some maintenance activities going on. During this phase, we also have other activities going on in parallel. This is what we called the post-market activities. So during this phase, it's also very important as a manufacturer to look all information in the field that is related to safety. So for example, as we've seen before with the databases, there we have examples of similar devices. So we should also analyze this, analyze whether we have new or revised standards, whether customer feedback, healthcare professionals, family members, any feedback that could help us improve the software. Sources of harm. We've been speaking about harm throughout the presentation. And there's quite a list of potential sources, and specifically for software, we have the process itself, the radiotherapy process. As you've seen, we have the examples of the wrong patient being treated, the wrong side of the body being treated, accessory not used, which causes treatment delay. It can cause harm to the patient, for example. Another source, labeling, so manuals. Are they up to date? Is the translation correct? Are they available? And the third source is data. As we've seen with the example of the database, which was accidentally deleted. There we also have different types. It's data storage, transfer, integrity, security. Speaking about security, cybersecurity. Cyber attacks also play an important role in leading to harm to the patient, not only in radiotherapy. Here we have two examples of two articles published in newspapers where cyber attacks led to treatment delay. In one of the cases, the patient had to be transferred to a different hospital because of this, and the patient died. There are different platforms where one can find information about cyber attacks in healthcare industry. So just to give you an idea, in the last 2 years from June to June, there had been around 450 reported cases that led or that consisted in a 56 system downtime. So you can imagine a 56% system downtime for a hospital or a clinic, what this means in terms of harm to the patient. And with that, I hand over back to Naval for impact and new technologies on patient safety. Sorry.
Thank you. Okay, let's talk about new technology. Actually, not exactly new technologies, but more the impact it has on healthcare products and therefore on patient safety. I want to look at it from not really from the technology point of view, but what is the problem that those technology can solve? I mean, you are exposed to a lot of innovation, technology is here, but here the topic is really what can we do with those innovations? How can we help the healthcare provider to deliver a higher quality treatment? So I selected some trends and some aspects that are really seeing a big impact today. I'm starting with automation. This is really very important topic because you saw that many of the mistreatment that happened were a lot due to errors from users, workflows, and these kind of things. Imagine if we could automate much more of this. This would mean that we would have less space for errors. And today, we really finally see a lot of improvement in that domain. Let's talk a bit about segmentation. So segmentation, for those that are not familiar with it, is the delineation of objects. In medical device is the delineation of organs, and this happens in 3 dimensions. And this can really take a lot of time. This is really very manual work. It requires specialists, and this is one of the causes why the treatment between the time the patient gets the CT and the time where the treatment is delivered, it can take 1 to 2 weeks. And there have been research on these topics for such a long time. But to say the truth is that it's only with the deep learning, with AI, that finally we have solutions that can be used at the clinical level. So this is really a game changer. As well, talking about AI, you can use now AI also to create plans, so the optimization that I talked about in the beginning. And this is going to also save a lot of time. So reduces procedure time, this is very important, reduces the variability between user, from one user to the other, having really standard care, but doesn't mean that everything is going to be automated and the machine is going to do everything. No, we still need specialists. And those specialists now are going to be able to really focus on the patient instead of doing this manual work that a machine can be doing. What is also interesting to see is that with this automation, you are able then to create and to adapt the plan more often. Think about this patient that is going through the treatment for 3 weeks. The patient might lose weight, the tumor might shrink, you have movements, internal movement in the body. You want to be able to adapt this treatment daily. It's not always possible because it's taking so much time. But now, if we really have this fully automated part, then this will be much more accessible. This is actually happening today, actually. Now we have solutions that can create this automation and adapt the plans. Different aspect, mobility. So, you and doctors are all carrying mobile devices, tablets, laptop. We are all over the world traveling. One challenge that we see today in healthcare is the access to specialists. This is really becoming a problem. And with having the ability to store data in a safe way, it means also that we are creating this communication channel and the access to experts. So this is very important to make sure that we are delivering the right, that the right treatment is delivered. Finally, decision support. This is also a very interesting topic that is happening. We didn't touch it too much, but one aspect of patient safety and how not to cause harm, it's also to initially prescribe the right treatment. But patient can react very differently one to the other. But today, with all the available data that we have the possibility to access this data and have as well algorithms that are going to interrogate this data to see what is the best treatment for this patient. We are talking today about patient twinning. So it's a bit the same idea as a simulator in aviation. So you could try a treatment on this digital patient, or I think we are more still at the level of having a digital organ. Let's say that the patient have lung cancer, so you would then modelize this organ and see how this patient would respond to the treatment. And the ultimate goal here is to get into personalized treatment, making sure that the treatment that you are going to give is the best treatment for this patient. So safety, it's a very serious topic, right? And we don't want you to come out of this presentation thinking, oh my God, this is so dangerous, radiation therapy. They don't know what they are doing. They are making so many mistakes. This is not the case, really. Radiation therapy is actually a highly regulated medical practice with historically low error and injury rates. I cannot say that we can talk about zero harm. That's actually quite impossible. The accident happens, errors happens. Human errors, we talked also about data transfer from one system to the other. Things can happen. But the most important is that this whole domain is very regulated, that we are always improving the product with the innovation, of course, but also with the process that really guide us and tell us how to follow up on any issue that is discovered. And with this, I think we want to thank you for your attention. And if there is any question.
Yeah, thank you.
I have a question. So, in the various cases that you showed us where harm was done to patients usually not following the standard procedure, have you ever thought about how you could use software to prevent these cases? I mean, it would be something simple, like having an app and the patient has to press a button before the machine won't even start or something like that.
I like the question. Shall I take it? Or you want?
Sure, you can take it. You can continue later.
There are actually already solutions on the market. So you can have, for example, barcodes. You have patients coming with the cart, and then you have the barcode. You have a solution, I think, with palm readers as well. But it's also interesting, even with those solutions. So you have to think first, okay, let's say it's the cart, the barcode solution. There are cases where patients, like I heard really cases where the patient would tell to their brother after 2 weeks of treatment, because it's a non-invasive treatment. The patient comes, laying on the table, it's 10 minutes, they don't feel anything. Oh, today I cannot go, but I don't want to miss the treatment because maybe they will cancel the other one. Just go for me. And they give it's very rare, but I really heard this anecdote from colleagues that have clinical background. And then also, okay, let's say that, what was the second example? So if you have the palm reader, for example, you need also to make sure that the therapist is going also to select the right thing. So, I mean, we can, of course, a lot improve this, but yeah. Yes?
How are cases protected legally when something like this happens? Like for your company or?
Ah, that's a good question.
Yeah, well, there, as I've mentioned, for example, besides of the regulatory aspects, which we don't have the answer for that, you have seen there are some public databases, and for example, manufacturers, medical device manufacturers are obliged to report these incidents in these databases. So you have other people which are voluntary, like customers, healthcare professionals or patients, but the medical device manufacturers or a clinic, they're obliged to write to these databases to put down there what happened. And then other medical device manufacturers as well look at them and also think, is this applicable to us? Yes, no, they go through the process and think, oh, if this is applicable, what can we do? If not, then we've already checked it just in case. But of course, there are national, international regulations. I mean, many, many standards to be followed. So it's also a lengthy process. Sure.
Is it possible that even if your product is, follows all the standards, follows all the regulations, if there's a certain number of reports in those databases from customers or patients that someone will then tell you, hey, this product, we should take it out of the market. It's not, we cannot use it anymore, not viable.
I mean, here we have many things going on. Like, you might have, for example, this monitoring of the backups, saying, okay, in these clinics in this country, we know that the backups are running, everything is fine. But there are some countries that by law, they don't allow having a monitoring or internet access, for example. So you cannot monitor these backups. So you need to make sure as well that you allow them to have their backup system as well, to make sure that they can tell them, I don't know, maybe in the manual's instructions, please do backups regularly or for important information. So there are many, many things that play a role, not just the software itself, but also like country-specific regulations.
But just maybe to add, if it's actually proven that there is a problem with our software, we are obliged, and that there is harm that can be caused to a patient, even if there was no harm, but that a customer notice, okay, we see that we can make this mistake very easily. Luckily, it was caught later in the process, so nothing happened for that patient. We will react. We cannot leave if it's proven that there is a problem in the software, then we have to provide an upgrade. And then, of course, as Marta said, it's up to the customer to take the upgrade or not. But they have to sign and acknowledge also that, hey, there is something here, we know about this issue, and it's up to you to make the right decision. But we are obliged to also follow up on our issues.
Yeah, because even in these public databases, there are customers that write down that our products, for example, caused harm or there was an injury. So we also have to look at all this information from the post-market activities, not just other devices, but also reports that concern our own devices, probably filed in by other clinics, hospitals, or professionals.
I think what was interesting in the slide of Marta with the process, it's everything related to safety doesn't stop at the production. It continues afterwards. Yeah.
One more question. Do you know if medical staff is generally welcoming the decision support and the arrival of AI, or is it more reluctant?
I mean, that's a good question. You have to think that the clinics or hospitals, they already have their daily workflow. They're used to it. There's a lot of patients. So whenever something new comes in, you need some time to train the users, to introduce it. So, I mean, nowadays also new technology helps to deliver treatments faster. So the more patients they treat, also it's a success. So it depends case by case.
Mm. And it's like everywhere when there is new innovation, you have the early adopters always. So these are the ones that are going to use those those innovation, then normally they publish, they talk about the improvement, and then the others will follow a bit later. But today, I think, like, for example, the example of automatic segmentation, I think people are quite convinced about the benefit. It's very, very painful to contour organs over 100 slides, one after the other. So they're happy.
And multiple patients.
And?
Multiple patients.
Yeah. Multiple patients, yeah.
It's not just one.
Yeah.
Any more questions?
If there's no more questions, then I would say thank you for being here.
Thank you. For oh,
thank you.
Look at us. Thank you.
This one's for you.
She deserves to organize everything.
Thank you. Thank you. Thank you so much.